All right. Good morning, Willamette High School science students. I want to go over the periodic trends activity with you, and I apologize if you watched the previous video where you didn't get to see what I was doing. My deepest apologies. I'll try that again with this screen. Here we go. So you're going to need your periodic table for this as well, and it will be super helpful for you if you have that item out with you. And so don't neglect using your periodic table, okay? You'll need that. So here we go. That being said, one of the things that you're going to want is this activity handout. You're going to want this handout for yourself, and you're going to want one of the four versions of this handout, right? Atomic radius, ionic radius, ionization energy, or electronegativity. And I'll refer to what each of those are in just a moment. Okay, that's helpful. All right. First of all, I want to flash back for just a moment to the box that you have on your periodic table that has little numbers on the side. Let's take sodium, for example, which shows 11 positive and negative charges in its box right there. But it also shows the number of outer electrons right over here in this last number on your box, right? So this is a review. So I hope you're picking that up. And then, of course, underneath there somewhere is 23.9, I believe, somewhere around there. Excuse me, which rounds to, or yeah, 22.9, which rounds to 23. Minus 11 means you have 12 neutral particles in this atom, right? That's how we did that. All right. So that being said, I'm going to take you over to here to show you what we're going to be plotting today. And while you're doing that, when you have some questions, let's say before you do that, you're going to want to use your slide notes for your predictions. You can use your slide notes through all of this, by the way. So it should help you understand a little bit about the size of the atoms. You had that in your slide notes, but also what happens, and this is when you go down a column. All right. And then what happens as we go left to right? What happens to the size of the atoms? Okay. Make sure that you're paying attention to what this is asking you. All right. So as you go through this, each of you are going to take on one of these four sample sizes. You're not going to do all of them, just one. So atomic radius, we're going to say that this shows you the relative size of the atom. How big is the atom across its radius, its nucleus? All right. When we talk about ionization energy, we're talking about energy needed to remove or gain an electron. Really, it's about moving the electron, those valence electrons, actually. Now, other ones get involved, but for the most part, we're talking about valence electrons that jump from one to another. You'll see more of this, excuse me, in the next video. Ionic radius is how big does the atom get when it bonds, James Bond. So when it becomes an ion, that means it adds or eliminates an electron, one or more electrons. All right, ionic radius. And this is only for the metals and the non-metals when they're bonding, James bonding. Electronegativity refers mostly to the non-metals' ability, not always, but mostly, non-metals' ability to attract electrons, and then they bond, James Bond. Ionization energy is referring to metals, for the most part, but not always, ability to lose those electrons, right? So we know that there's going to be this kind of a bonding happening. We'll talk about that more in the next video and the next activity. All right, so I'm going to do two samples. I'm going to do the atomic radius, and I'm going to do the ionization energy. The reason I'm not going to show you the ionic radius and the electronegativity is because the circle versions are exactly the same process. The line versions are also the same process. They're just different properties of the elements, but they're referring to amounts. Okay, so one thing I want you to do, even before we get going here, is I want you to identify where the rows of the elements are so that when you're looking at your periodic table, you'll know which ones are where. Okay, this is row number one. Row number one has elements 1 and 2 in it as we go from the left side of the periodic table to the right side. And then row number 2 goes all the way down to element 10. On this chart and on the periodic table, it starts at element 3 and it goes all the way across to element 10. Oh, excuse me, row 2. Excuse me. Scratch that, change that. Row number 3 starts at sodium and it goes across to argon. We're going to mostly deal with elements in these first 4 rows, but later you're going to see some questions that also relate to rows 5 and 6. So don't think this doesn't count for them as well. All right, row number 4 starts at element 19 and it goes all the way to 36. I know there's some numbers that are skipped in here. Numbers 21 through 30. And there's a reason for that, because we can get the idea without putting a whole bunch of other elements in here. All right, so let's get plotting. So I'm going to start with atomic radius, and we're going to deal with family 1, which is the +1 family. I want you to have that out here. Write that on there. All right, we're going to take, I'm going to take the ruler and show you what we're going to do here. You have 2 sides of most of the rulers in our classroom. And we're going to use the side that has the centimeters on it and millimeters, right? The centimeters are the numbers 1, 2, 3, 4, 5, 6, 7. The millimeters are in between the numbers. So half of the way to 1 is 0.5. Don't use fractions, use decimals. So if you count all of the lines, it's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. So really, there's 1.0 at the end here. And then you go 1.5, 1.6, 7, 8, 9, 2.0. We're not going to get any further than 3 in this activity. So you got to pay attention to this and use that side of your ruler. All right. So let's go over to hydrogen, which is our first element, 0.53. And if I were you, I would check off as you put these in. Now, we're going to make a diameter of 0.53. So I'm going to try to make these like centered in the box. Nothing bigger than that or nothing close to the edge just yet. All right, so 0.53, I'm just going to draw a line there because actually I should draw 2 points. Sorry. And then I want to draw a circle. You can draw the line though, actually. That's okay. And then I'm going to draw a little circle. It doesn't have to be perfect. When you get done, please put the symbol. This will help you a lot. All right, then I'm going to drop down to number 3, which is lithium, 1.67. So I'll take my ruler. I want to sort of center it in the middle. And 1.67, there's the point. There's the 1. This sort of helps me see about how big my circle should be. And again, we're going to get it close. It's not going to be perfect. I'm going to drop down to number 11, which is 1.90. And that's, I need to put lithium on my last one there. All right, so 1.90 is going to be sodium. And it goes just about there to there. What I'm hoping that you're seeing is that I do this. We're getting bigger as we go down the periodic table. So there was my sodium element number 11. All right, now I'm going to get down to number 19 in row 4, 2.43. Wow, that's a big number, isn't it? 2.43. Okay. All right. So let's do the big one. This takes up almost the whole ding dang circle. I mean, square. And it should, because it's a big ding dang atom. All right. This is, what did I say? Potassium. Right. And then rubidium is underneath that. So you can almost guess right now how much bigger rubidium is. And then, of course, francium, the biggest atom on the periodic table. It's an exciting atom. Those outer electrons are way, way out there. These are the boom electrons that cause nuclear reactions, by the way. Just saying. All right. That's how you do a column. Okay. I'm going to do one across, and we'll start at number 3. We've already done 3. We'll go to number 4. So let me check off number 4 here. And it's 1.12. You can almost see what's happening already. 1.12. You see that's a little bit smaller? Yeah, go figure that one. All right, and then when we get to the other side, I'm going to do element number 2, and I'm going to do element number 10, and then we'll move on to the next handout. Okay, so element number 2 is 0.31. You can see that's smaller than hydrogen. It is. It should be. Okay, 0.3. Ooh, dingity dangly. That's small. Woo! Yeah, look at that. All right, that is a tiny atom. That is actually our smallest atom, helium. All right, I'm going to do one more, and that'll be, what did I say? Neon, number 10. That's 0.38. So that's a little bit bigger than helium. So again, you should see that the elements are getting bigger from top to bottom, and they're getting smaller from left to right. There you go. All right, I hope that's helpful. Now, over category number 2, now this holds for all of your samples. You can do this on all of them. +2, +3, plus or minus 4. This is going to come in handy for our next activity. -3, -2, and a -1. And what we're going to see in the next activity, I'll give you a preview, is that the opposites attract really well. 8 family is 0. They don't need any electrons to bond, James Bond. All right, element number 4, I think that was beryllium, so let me make sure I get the Be in there. Make sure you're writing your symbols. We did helium, and then we did neon. All right, that's how you work the atomic radius page. And the ionic radius page works exactly the same. Your values are different, but the process is exactly the same. All right, now I'm going to do 2 and 3, 2 and 4. And again, both ionization energy and electronegativity, the values are different, but the process is identical. All right. Again, I'm going to do the +1, +2, +3, positive or -4, -3, -2, -1, 0. Now, the reason we don't have any of these elements in this big gap down here is because they are in the transition metals family, and they are not regular patterns. So we kind of exclude them when we learn this activity. All right, now on this one, we're using lines instead of circles. So I'm going to start these on the bottom. And for the first one, I have hydrogen at 1.31. 1.31. So I'm going to go up from the bottom. And it looks like 1 and 1, 2, 3 little dashes. All right, pretty small line. I'm going to put a T on the top. When you do ionization or electronegativity, you use like an upside down L. All right, see the difference? Okay, that's all you need. All right, this one's hydrogen, and I'll do the one below it. So let me click that off. And then lithium is the one below it. So we're going to go 0.52. And there's that little T. This is lithium. Write the symbols in. What you should already be seeing is that the amount of energy that it takes to remove an electron gets smaller and smaller and smaller. Right? That means that these elements from top to bottom get more boom reactive. All right, sodium. All right, sodium, yeah. 0.5. So it's slightly smaller, but not that much than lithium. just a skosh. So I'm going to make a skosh. All right, there's sodium. All right, I'm going to drop down and do, that's not a letter T, by the way, it's just a symbol. Uh, Potassium, number 19. And it's 0.42, so it's a little bit smaller than the last one. I'm going to go to 4 little dashes, 1, 2, 3, 4, and a T and a K for potassium, right? Okay, now let's go over to helium over on the top, and that will be element number 2 on your chart. You can see it's 2.40, meaning that it has way almost twice as much, not quite, but almost twice as much as hydrogen. That means it's hard to pull an electron out of there. Those things are tight. All right, 2.40 for helium. So I'm going to go a little bit past 2. Oh, wait, no, 2.4, didn't I say? Yeah, I got to go 2 and 4 little lines past there. Okay, I don't want to shortchange you. All right, and there's helium. All right, just even looking at the lines, you can see from left to right, these are harder to remove electrons. Easy, hard. Got it? Okay. Hope you got that. All right, let me do, I'm going to do element number 10, which is neon, right below helium, and we'll verify what we were just talking about. All right, that's 2.1 on the rounded. I rounded that to 2.1. I hope that's okay. All right, and this is neon. What you should see here is that helium is bigger than neon. Neon should be bigger than krypton. So let's do krypton right below that, or excuse me, argon. Let's do number 18. That's our last one. Look at how it changes. It goes from 2.0 down to 0.42. That's because it's a much bigger element. All right, so argon, what did I say? Oh, no, sorry. 1.52. 1.52. Yeah, sorry about that. Okay, so 1.52. And so that's 1.5 approximately. Let's get that in there. But definitely, you can see that argon, so krypton, argon is shorter than neon. Okay, there you go. That's exactly how you do this entire packet. But I will give you one little tip on electronegativity. In electronegativity, I want you to notice when you get this one, look at helium number 2. Number 2 has dash on it. I want you to include that in your table. And number 10, and number 18, and number 36. The reason you're going to find dashes on these is because these, with their 0, they don't bond. So let's angle that into our paper. Do not bond. James Bond. Okay? They don't need to bond with anybody. They have met the rule of octet, which we'll talk about in the next activity. Now, once you get done with your 4, each of you get done with your table, you're going to take that in your group now and talk about it, right? Give each other help on these questions. Talk about these questions together. What happens to the radius as we go down? Again, if you are struggling, go see your slide notes on the atomic patterns that you just had before this activity. All right, that'll help you answer most of these questions. And then as you get down, you'll have similar questions on ionization energy. And then when you get down here, you have to choose which element has the largest radius and which one has the smallest. Look on your table. Look on your table. All right. In this next portion, this is a little trickier because you have to jump out of periods 1, 2, and 3, and you have one that's in period 5, and you have one that's in period 6. So you have to use your pattern to guess and predict which one is actually largest. All right. That's number 2. When you get to number 3, you do the same thing. Which element has the larger ionization energy, right? Which one takes more energy to pull an electron away? Use your patterns on your table to help you determine that. All right. Same thing with number 4. Now you're going to be challenged between fluorine and bromine. They're in the same column, but they exhibit different properties slightly. All right. Then give me a conclusion. Get these into your notebook, and we will start talking about bonding, James bonding, in the next activity. All right. Good luck.